This is the type third. In that we are going to see first limit x tends to 3. The function is x square minus 9 upon x minus 3. Here what we can know, this is the function fx, and this function we have seen the methods, we have seen the solving methods for the limits. First we have seen the substitution method, and second we have seen the tabular and approximation method. Now we are talking about third way to solve limits, that is factoring method. So if this limit is x tends to 3, x square minus 9 upon x minus 3, if we put directly x is equal to 3, then first term in the numerator we have x square minus 9. If we place x is equal to 3 at the place of x, then x now is equal to 3. Then 3 power 2 is going to 9, and 9 minus 9 is 0. So numerator what we have 0. Now we are going to see the denominator of that function. So in denominator we have x minus 3. Now we are going to put x is equal to 3, then 3 minus 3 is 0. So this is the form which we are seeing after solving the limits. But this is the indeterminate form. And we know how to solve this type of problems in the limits. There is a L'Hopital's rule, but we are not going to talk about that. We are going to see the factoring methods, how we can solve easily that type of limits. Okay, let's see. There is if we analyze the first term in the numerator, there is a x square minus 9. We know that if we have seen the algebraic function like a square minus b square is equal to, in the first round bracket we have a plus b, and the second round bracket we have a minus b, and in numerator we have x square minus 9. We can make that type of algebraic function equation, so that will easily solvable. And x square, if we 9 we break 3 power 2, then the same algebraic equation we can apply here. Then that is going to be, if we talk about the numerator, this is going to be x plus 3 and x minus 3, and in denominator we have x minus 3. We can see that x minus 3 upon x minus 3, this term is going to cancel. So what we have remaining, that is x plus 3. Now this is the function. Now this is the final function. What we can say that the final limit is going to limit x tends to 3, and the function's value is going to x plus 3. And if we put x is equal to 3, the function's value is going to be, let me change the color, this is going to be the 6. This is the solution. And okay, let's see the another type of problem, that is factoring method. Another place where we can use that, the limit x tends to 5. There is a expression, algebraic expression. This is a polynomial expression. We have x square minus x minus 20, and in denominator we have x minus 5. And x minus 5, it means that what we can do, if we first see the numerator, and this is a 20, and the denominator we have minus 5. So we can see that, like if we break that expression, so what we can get, like 5 4 is 20. So this is going to be x plus 4 and x minus 5. We can directly get that with the expression, polynomial expression. So, and in denominator we have the x minus 5. Yes, so x minus 5. Now we can see that the term x minus 5 is going to cancel. Yes, so this is going to x plus 4. This is the final function's value, and let me write that limit x tends to 5. Limit x tends to 5. The function's value is x plus 4. Now if we put x is equal to 5, the limit's value is going to be 9. Okay, let's see one more problem. Okay, let's see the one more problem, that is, let me change the color so that is easy to visible. Okay, third, that is limit h tends to 0, and in the round bracket we have h plus 4 whole square minus 16 upon h. So we can see that in the numerator there is a term h plus 4 whole power 2 and minus 16. Now we can say that if it is going to be squared, then this is going to be plus 16, and now we can cancel out the minus 16, because we have the algebraic formula like a plus b whole square is equal to a square plus 2ab plus b square. So we know that according to that formula I'm going to solve this, and what I'm doing basically, I'm factorizing that term. So that is going to be h square plus 8h plus 16, and there is a minus 16 upon h. So here the term, we can see that the term 16 is going to cancel because this is a plus term, this is a minus term. So we have a h square plus 8h upon h. Now we can take common. Now we can take h as a common from the numerator. So that is going to cancel with the denominator of h. So the final what we can have, that is h plus 8, the function's value. What I'm doing here, let's see this term. What I'm doing, I'm taking h as a common and h plus 8, and we have in denominator h, so that h is cancelled. So that's why I'm writing this. So this is the final function's value, and if this is going to be, let me change the color. Okay, so that is what that the limit h tends to 0, h plus 8 is look like this, and the final look of this limit is going to be for this function. So that is easy and it is solvable, so we can put h is equal to 0. Now the function's value is going to 8.